Alright, so today we're going to look at the volume of cylinders. And when you're dealing with cylinders, clearly the top and the bottom are circles. So there's some information we need to recall about circles that are going to be useful in this lesson. So let's recall the measurement of a radius and diameter. Now, radius is a measurement on a circle. Let's assume these two circles are of the same dimensions, same size. So the radius would be the center to the edge of the circle, or the outer rim. And we call R stands for radius. And then if you have a circle and you have the distance entirely across going through the center, that's called the diameter. And clearly, if these two circles are of the same size, my diameter is 8, then I can also conclude that the radius must be 4, halfway across. If you're given a radius is, let's say, 5. So if I know the radius is 5, but I would like to know what the diameter is, then you would just do 5 and another 5 on each side. It would be 10. Diameter would be 10. So let's write down some important facts as how they're related to one another. That the radius is half of the diameter. And the diameter is double the radius. All right, so those are the measurements on a circle. And one of the other things we have to remember is how to find the area of a circle. And that formula is, and I put it in red because we're going to have to revisit this soon. Pi times r squared. And in case you forgot what pi was, it's a number that has a value of, we'll estimate it to be 3.14. So in our calculations, whenever we see pi, pi represents a never-ending decimal, but we're going to just use 3.14 as an approximation, which is why the lines are squiggly. This means approximately. I want to show you what this unit of measure actually means in terms of all the other measurements you've probably seen. We have something called 0 dimensions, 1 dimension, 2D, and 3D. All right, so as far as geometry goes, what exactly are these and how are they measured and what do they measure? So first of all, 0 dimensions is a point, right? You don't have a length, a width, a height. It's just literally a point, and that looks like this, and it's called a point. In 1 dimension, we actually have a distance. And that distance, for this example, I'm going to just stick to centimeters. Could be measured in centimeters. And again, we're measuring distance. And then you have 2 dimensions. And 2 dimensions is like a tile, a flat square tile, a piece of paper, something that has 2 dimensions, which would be like a length and a width. Then your units would look like this. So if you're measuring area, length times width, you would end up with units that look like this, centimeters squared. And then if we were measuring something that looks 3-dimensional, like a box, and you can fill it up, that's called volume. Volume is how much something fills up. And because you have a length, a width, and a height, that's 3 dimensions. So we're going to say centimeters cubed. All right? So in this particular unit or section, we're going to be looking at this particular type of measurement. So when you see that little 3 in the exponent, it doesn't mean you have to do a math calculation with it. You don't have to take anything to the third power. It's just letting me know that your units of measure are representing a volume that's a volume quantity or volume amount. All right. All right, so let me tell you the formula for volume of a cylinder. So a cylinder looks like a can. You got a circle on the top and a circle on the bottom. And the top is the same as the bottom, so the same dimensions. So we're going to say that this entire region at the bottom, the area of all of this bottom section, is going to be called B. That's the base. Okay, and the height is the length on the side, or how tall the can is. So the volume is going to be capital B times H. Now it's very different from lowercase b, because lowercase b is strictly length. Capital B is the entire space, which is the whole area of the bottom. So in geometry, capital B is an area calculation. Lowercase b is just a length on the bottom of a shape as the base. So to be more specific, let me show you what that means. This here is going to represent the area of the base. Or H is going to represent the height. Now, the area of the base. The base is in the shape of a circle. So because the base is the shape of a circle, our formula is going to become pi r squared times h. Okay, so that is a specific formula for a cylinder. Okay, and I color coded this so that you can see that here we have base, this area, times the height. Now, we would have to calculate what that base is, which is why the formula is in here. Pi r squared, that's this entire circle. Once you find the area of that circle, then you just multiply it by the height. Okay, so let's look at an example and put this into action. So you see how that works out. So let's call this example 1. Find the volume. And you're given a cylinder. And the height of that cylinder is 6 meters. And the radius given for the top is 3 meters. Now, to find the volume, we're going to use a formula. Volume equals base times height. The shape of the base is a circle. So we're going to find this area here. That's my capital B. And to find it, I need to know the radius. Well, if the top and the bottom are the same circles on a cylinder, then I'm also going to say that the radius on the base is also 3 meters. Sorry, it's dark, you can't see it, but the radius on the bottom is also 3. So we're going to go ahead and start filling this in. The base, which I'm going to use area of a circle, pi times the radius squared times 6, which is the height. All right, and then you end up with volume equals pi times 9 times 6. And now it's just a calculation. You might want to grab your calculator now. Pi, remember over here, was really 3.14 as our abbreviation. We don't want to write all the decimals down. That's a close enough approximation. Times 9 times 6 is 56. And then together those two. And the units are meters cubed. All right, example 2. Example 2 is going to be the same type of example, except what do I do when I have one of my dimensions missing? And I'm going to show you how you can find the missing dimension. So this one says that you want to find the height if the volume is 314 inches cubed. And we're given a cylinder it's laying on its side. So although the cylinder is laying on its side, this would still be the height, right? If my cylinder was this way. So this would still be my height. And they're giving me that this entire distance all the way across that circle is 10. And I'm supposed to find the height. Okay, so that's how we're given. So to find the height, we're going to use this formula that we already know. And in this formula, this is going to be the measurement of the base, the area of the base times the height. So what is the area of the base? Look at this shape. What's the area of that shape? Right? And that's a circle. So I need to find pi times r squared. That's the area of the base times the height. So V, I already know. It's 314. So I'm going to plug that in. They gave that to me. Pi, I know, is 3.14. I gave that to you in the before the first example. Right here. We're going to use that approximation. And r squared. We don't have r, we have a diameter. Doesn't mean I can't find it. I do know that the diameter is 10. And we discussed earlier, if my diameter is 10 all the way across, then my radius is half of the diameter. So it would be 5. Okay, so now I'm going to plug in a 5 from r. And my height, I don't know that one, so leave it as an h. So now we pretty much have everything as a value except for h, so we can find h. So this is going to be 314 equals 3.14. 5 squared is 25 times h. And so these two numbers multiplied together is 78.5 times h. And we still have 314 on this side. And now to solve this, opposite of multiplying is to divide. And in dividing that, you get approximately 4. Since pi was already approximated, we know that this answer is going to be approximate also. We didn't use an exact value for pi, so that is the height. And we don't have to put inches squared or cubed because height is a linear distance. Okay, it's not an area, it's not the volume, it's the linear distance. So we can go ahead and just leave it as 4, since it's in inches, the volume was in inches, then we'll say 4 inches. Okay, so that was the height. And let's look at another example. 3. And we have a jar. They say it's a jar of salsa. I'm just going to make it look like a lid on the jar. And it's not full. and it's 10 centimeters in height, and it's 5 centimeters in the radius, and it's salsa in the can that remains is 4 centimeters from here to here. Okay, so we have 4 centimeters of salsa left in the can. That's the height. And the question is asking how much salsa is missing from the jar. All right, so we're going to assume that all of this salsa, which will make it red, is what's left in the jar. And they want to know how much of it is missing. Well, think of the empty space inside this jar as being another little cylinder that's a cylinder of air and a cylinder of sauce. So we really much want to focus on the cylinder of the air in the jar. So the volume of the empty space. All right, so what would be the dimensions of that empty space? So we have 5 centimeters on the base, which would be the same 5 centimeters here. I'm sorry, the radius of the base. And we have a height of what? If the entire jar was 10, we don't want to include these 4 centimeters of salsa, so we're left with 6. So volume is going to be base times height. Volume we don't know. The base we do know, which is the same as the top, is pi, area of a circle, right? The base is a circle, so we want pi r squared for that area of the circle, this circle. So pi times 5 squared times the height, which we said would be 6. So let me write that down. That means this was 6. All right, so together 6 and 4 makes the 10 of the entire jar. And so now we have volume equals 3.14 times 25 times 6. And then you get volume equals 471 centimeters cubed are missing of salsa. And there you go.